Good day. Today, my report is all about emerging technology. So, what is emerging technology? Emerging technology is a term generally used to describe a new technology, but it may also refer to the continuing development of an existing technology. It can have a slightly different meaning when used in different areas such as media, business, science, or education. The term commonly refers to technologies that are currently developing or that are expected to be available within the next 5 to 10 years and is usually reserved for technologies that are creating or are expected to create significant social or economic effects. Emerging digital technologies have generated new opportunities while creating new legal challenges, particularly related to copyrights, trademarks, patents, royalties, and licensing. For example, the development of new digital communication technologies and media has given rise to novel issues relating to the digital reproduction and distribution of copyright works. The federal government, affected industries, and groups advocating for the public interest have taken action to craft appropriate protection and offer legal certainty to copyright owners, digital technology companies, the public, and other interested parties. Here, the listed below are the top new technology trends in year 2022, or the latest one. First, the computing power, smarter devices, quantum computing, datafication, artificial intelligence and machine learning, extended reality, digital trust, 3D printing, genomics, new energy solutions, robotic process automation or the RPA, edge computing, quantum computing, virtual reality and augmentation reality, blockchain, Internet of Things or the IoT, 5G, cybersecurity, deep learning, and serverless computing. So, what is artificial intelligence or the AI? Artificial intelligence is the simulation of human intelligence processes by machines, especially computer systems. These processes include learning, reasoning, and self-correction. AI technology has been used to turn databases into useful intelligence and deliver answers to customer and stakeholders' questions in real time using a chat-style interface. Apps using artificial intelligence can also track massive amounts of small data like transactions, sensors, equipment productions, and the use solution to boost productivity in those areas. AI is also making complex medical diagnosis faster and more accurate with its ability to access and analyze vast data sources and against diagnostic data. Personal digital assistants are among some of the most popular AI applications. AI refers to the simulation of human intelligence in machines that are programmed to think like humans and mimic their actions. The term may also be applied to any machine that exhibits traits associated with a human mind, such as learning and problem solving. The ideal characteristic of artificial intelligence is its ability to rationalize and take actions that have the best chance of achieving a specific goal. A subset of artificial intelligence is machine learning or the ML, which refers to the concept that computer programs can automatically learn from and adapt to new data without being assisted by humans. Deep learning techniques enable this automatic learning through the absorption of huge amounts of unstructured data such as text, image, or video. So, what is AI? When most people hear the term artificial intelligence, the first thing they usually think of it is robots. That because big budget films and novels weave stories about human like machines that wreak havoc on Earth. But nothing could be farther from the truth. Artificial intelligence is based on the principle that human intelligence can be defined in a way that a machine can easily mimic it and execute tasks, from the most simple to those that are even more complex. The goals of artificial intelligence include mimicking human cognitive activity. Researchers and developers in the field are making surprisingly rapid strides in mimicking activities such as learning, reasoning, and perception, to the extent that this can be concretely defined. Some believe that innovators may soon be able to develop systems that exceed the capacity of humans to learn or reason out any subject. But others remain skeptical because all cognitive activity is laced with value judgments that are subject to human experience. As technology advances, previous benchmarks that define artificial intelligence become outdated. For example, machines that calculate basic functions or recognize text through optical character recognition are no longer considered to embody artificial intelligence, since this function is now taken for granted as an inherent computer function. AI is continuously evolving to benefit many different industries. Machines are wired using a cross-disciplinary approach based on mathematics, computer science, linguistics, psychology, and more. Let's proceed to the pieces of modern AI. First, the machine learning. To a large extent, machine learning is actually the end goal for the most of the cutting-edge work in AI. Machine learning generally refers to techniques that allow computers to gather data and build their own pathways for analyzing that data. There is no single approach or algorithm that defines machine learning. Instead, there are many different methods being used to produce machine learning capability. This means that an end user needs to know the details behind the specific machine learning process they are implementing. Next is deep learning. Deep learning is one of the most common approach for machine learning. With deep learning, computers analyze problems at multiple layers in an attempt to simulate how the human brain analyzes problems. Visual image, natural language, or other inputs can be parsed into various components in order to extract meaning and build context, improving the probability of the computer arriving at the correct conclusion. Neutral networks. These software models consist of five parts: a decision-making unit called a neuron, inputs, weight that can be assigned to the inputs, biases that shape the analysis, and a single output. Multiple stages of neurons can be stuck together to result in the multi-layered analysis found in deep learning. Here are the categories of artificial intelligence. Artificial intelligence can be divided into two different categories: the weak and strong. Weak artificial intelligence embodies a system designed to carry out one particular job. Weak AI systems include video games such as the uh, chess example from above and personal assistants such as Amazon's Alexa and Apple's Siri. You ask the assistant a question and it answered it for you. Weak AI, also known as narrow AI, an AI system that is designed and trained to complete a specific task. Industrial robots and virtual personal assistants, just like Apple Siri, is use weak AI. Strong artificial intelligence system. A system that carry on the tasks considered to be human-like. These tend to be more complex and complicated systems. They are programmed to handle situations in which they may be required to problem solve without having a person intervene. These kinds of systems can be found in applications like self-driving cars or in hospital operating rooms. Strong AI, also known as Artificial General Intelligence or AGI, describes programming that can replicate the cognitive abilities of the human brain. When presented with an unfamiliar task, a strong AI system can use fuzzy logic to apply knowledge from one domain to another and find a solution autonomously. In theory, a strong AI program should be able to pass both a Turing test and the Chinese room test. The four types of AI. First, reactive AI. It uses algorithms to optimize outputs based on a set of inputs. Chess playing AIs, for example, are reactive systems that optimize the best strategy to win the game. Reactive AI tends to be fairly static and unable to learn or adapt to novel situations. Thus, it will produce the same output given identical inputs. Limited memory AI. It can adapt to past experience or update itself based on new observation or data. Often, the amount of updating is limited and the length of memory is relatively short. Autonomous vehicles, for example, can read the road and adapt to novel situations, even learning from past experience. Next is the theory of mind AI. Theory of mind AI are fully adaptive and have an extensive ability to learn and retain past experiences. These types of AI include advanced chatbots that could pass the Turing test, fooling a person into believing the AI was a human being. While advanced and impressive, these AI are not self-aware. Next, self-aware AI, as the name suggests, become sentient and aware of their own existence. Still in the realm of science fiction, some experts believe that an AI will never become conscious or alive. Next is the application of AI. The application for artificial intelligence are endless. The technology can be applied to many different sectors and industries. AI is being tested and used in the healthcare industry for dosing drugs and doling out different treatments tailored to specific patients and for aiding in surgical procedures in the operating room. Other examples of machine with artificial intelligence include computers that play chess and self-driving cars. Each of these machines must weigh the consequences of any action they take, as each action will impact the end result. In chess, the end result is winning the game. For self-driving cars, the computer system must account for all external data and compute it to an act in a way that prevents a collision. Artificial intelligence also has application in the financial industry, where it is used to detect and flag activity in banking and finance, such as unusual debit card usage and large account deposits, all of which help a bank fraud department. Applications for AI are also being used to help streamline and make trading easier. This is done by making supply, demand, and pricing of the securities easier to estimate. Three cognitive skills of artificial intelligence. First, the learning processes. These aspects of AI programming focuses on acquiring data and creating rules for how to turn the data into actionable information. The rules, which are called algorithms, provide computing devices with step-by-step instructions for how to complete a specific task. Next is reasoning processes. This aspect of AI programming focuses on choosing the right algorithm to reach a desired outcome. And the last is self-correction processes. This aspect of AI programming is designed to continually fine-tune algorithms and ensure they provide the most accurate result possible. The advantage and disadvantage of artificial intelligence are good at detail-oriented jobs, reduce time for data-heavy tasks, delivers consistent results. AI-powered virtual agents are always available. Is under advantage. Under disadvantage, it is expensive, requires deep technical expertise, limited supply of qualified workers to build AI tools, only known what is being shown, lack of ability to generate from one task to another. Here are the examples of artificial intelligence or the AI. First, Google Maps and ride-hailing applications, face detection and recognition, text editors and autocorrect, chatbots or chatbots, e-payments, search and recommendation algorithms, digital assistants, social media, healthcare, gaming, online ads network, banking and finance, smart home devices, security and surveillance, smart keyboard app, smart speaker, e-commerce, smart email apps, music and media streaming service, and space exploration. Machine learning. What is machine learning or the ML? Machine learning is a branch of artificial intelligence and computer science which focuses on the use of data and algorithms to imitate the way that human learns, gradually improving its accuracy. Machine learning is a type of artificial intelligence that allows software applications to become more accurate at predicting outcomes without being explicitly programmed to do so. Machine learning algorithms use historical data as input to predict new output values. Machine learning is an important component of the growing field of data science. Through the use of statistical methods, algorithms are trained to make classifications or predictions and to uncover key insights in data mining projects. These insights subsequently drive decisions making within applications and businesses, ideally impacting key growth metrics. As big data continues to expand and grow, the market demands for data scientists will increase. They will be required to help identify the most relevant business questions and the data to answer them. Machine learning algorithms are typically created using frameworks that accelerate solution development such as TensorFlow and the PyTorch. Machine learning. Next is the primary categories of machine learning methods. First, supervised machine learning. Supervised learning, also known as supervised machine learning, is defined by its use of labeled datasets to train algorithms to classify data or predict outcomes accurately. As input data is fed into the model adjusts its weight until it has been fitted appropriately. This occurs as part of the course validation process to ensure that the model avoids overfitting or underfitting. Supervised learning helps organizations solve a variety of real-world problems at scale, such as classifying spam in separate folder from your inbox. Some methods used in supervised learning include neutral networks, naive-based linear regression, logistic regression, random forest, and support vector machine or the SVM. Supervised learning algorithms are trained using labeled examples, such an input where the desired output is known. For example, a piece of equipment could have data points labeled either F for failed or R for runs. The learning algorithm receives a set of inputs along with the corresponding correct outputs, and the algorithm learns by comparing its actual output with correct outputs to find errors. It then modifies the model accordingly. Through methods like classification, regression, prediction, and gradient boosting, supervised learning uses patterns to predict the values of the label on additional unlabeled data. Supervised learning is commonly used in application where historical data predicts likely future events. For example, it can anticipate when credit card transactions are likely to be fraudulent or which insurance customer is likely to file a claim. Next is unsupervised machine learning. Unsupervised learning, also known as unsupervised machine learning, use machine learning algorithms to analyze and cluster unlabeled datasets. These algorithms discover hidden patterns or data groupings without the need for human intervention. This method's ability to discover similarities and differences in information make it ideal for exploratory data analysis, cross-selling strategies, customer segmentation, and image and pattern recognition. It's also used to reduce the number of features in a model through the process of dimensionality reduction, principal component analysis or the PCA, and singular value decomposition or the SVD are common approach for this. Other algorithms used in unsupervised learning include neutral networks, k-means clustering, and probabilistic clustering methods. Unsupervised learning is used against data that has no historical labels. The system is not told the right answer. The algorithm must figure out what is being shown. The goal is to explore the data and find some structure within. Unsupervised learning works well on transactional data. For example, it can identify segments of customers with similar attributes who can be treated similarly in marketing campaigns. Or it can find the main attributes that separate customer segment from each other. Popular techniques include self-organizing maps, nearest neighbor mapping, k-means clustering, and singular value recomposition. These algorithms are also used to segment text, topic, recommend items, and identify data outliers. Semi-supervised learning. Semi-supervised learning offers a happy medium between supervised and unsupervised learning. During training, it uses a smaller labeled dataset to guide classification and feature extraction from from a larger unlabeled dataset. Semi-supervised learning can solve the problem of not having enough labeled data for a supervised learning algorithm. It also helps if it's too costly a label enough data. Semi-supervised learning is used for the same application as supervised learning, but it uses both labeled and unlabeled data for training. Typically, a small amount of labeled data with a large amount of unlabeled data. This type of learning can be used with methods such as classification, regression, and prediction. Semi-supervised learning is useful when the cost associated with labeling is too high to low for a fully labeled training process. Early examples of this include identifying a person's face on a webcam. Reinforcement machine learning. Reinforcement learning is often used for robotics, gaming, and navigation. With reinforcement learning, the algorithm discovered through trial and error which actions yield the greatest reward. This type of learning has three primary components: the agent, the environment, and the actions. The objective is for the agent to choose actions that maximize the expected reward over a given amount of time. The agent will reach the goal much faster by following a good policy. So the goal is reinforcement learning is to learn the best policy. A number of machine learning algorithms are commonly used. Neural networks. Neural networks simulate the way the human brain works with a huge number of linked processing nodes. Neural networks are good at recognizing patterns and play an important role in applications including natural language translation, image recognition, speech recognition, and image creation. Next is linear regression. This algorithm is used to predict numerical values based on a linear relationship between different values. For example, the technique could be used to predict house prices based on historical data for the area. Logistic regression. This supervised learning algorithm makes prediction for categorical response variables such as yes or no answers to questions. It can be used for applications such as classifying spam and quality control on a production line. Clustering. Using unsupervised learning, clustering algorithms can identify patterns in data so that it can be grouped. Computers can help data scientists by identifying differences between data items that humans have overlooked. Trees. Decision trees can be used to both predicting numerical values and classifying data into categories. Decision trees use a branching sequence of linked decisions that can be represented with a tree diagram. One of the advantages of decision trees is that they are not they are easy to validate and audit, unlike the black box of neutral neural networks. Random forests. In a random forest, the machine learning algorithms predicts a value or category by combining the result from a number of decision trees. Advantage of machine learning. First, easily identifies trends and patterns. Machine learning can review large volumes of data and discover specific trends and patterns that would not be apparent to humans. For instance, for an e-commerce website like Amazon, it serves to understand the browsing behaviors and purchase histories of its users to help cater to the right products, deals, and reminders relevant to them. It uses the results to review relevant advertisement to them. Next, no human intervention needed. With ML, you don't need to babysit your project every step of the way, since it means giving machine the ability to learn. It lets them make prediction and also improve the algorithms on their own. A common example of this is antivirus software. They learn to filter new threats as they are recognized. ML is also good at recognizing spam. Continuous improvement. As ML algorithms gain experience, they keep improving in accuracy and efficiency. This lets them make better decisions. Say you need to make a weather forecast model. As the amount of data you have keeps growing, your algorithms learn to make more accurate predictions. Handling multidimensional and multivariety data. Machine learning algorithms are good at handling data that are multidimensional and multivariety, and they can do this in dynamic or uncertain environments. Wide application. You could be an e-tailer or a healthcare provider and make ML work for you. Where it does apply, it holds the capability to help deliver a much more personal experience to customers while also targeting the right customers. Disadvantage of machine learning. First, data acquisition. Machine learning requires massive data sets to train on, and this should be inclusive, unbiased, and of good quality. There can also be times where they must wait for new data to be generated. Next, time and resources. ML needs enough time to let the algorithms learn and develop, enough to fulfill their purpose with considerable amount of accuracy and relevancy. It also needs massive resources to function. This can mean additional requirements of computer power for you. Next, interpretation of results. Another major challenge is the ability to accurately interpret results generated by the algorithms. You must also carefully choose the algorithms for your purpose. Next is high error susceptibility. Machine learning is autonomous but highly susceptible to errors. Suppose you train an algorithm with datasets small enough to not be inclusive. You end up with biased predictions coming from a biased training set. This leads to irrelevant advertisement being displayed to customers. In the case of machine learning, such blunders can set off a chain of errors that can go undetected for long periods of time. And when they do get noticed, it takes quite some time to recognize the source of the issue and even longer to correct it. Here is the example of machine learning. First is speech and image recognition, traffic alerts using Google Maps, chatbot or the online customer support, Google Translation, prediction, extraction, statistical arbitrage, auto-friend tagging suggestion, self-driving cars, ad recommendation, video surveillance, email and spam filtering, real-time dynamic pricing, gaming and education, and the last one is virtual assistants. Deep learning. So what is deep learning? Deep learning falls under the umbrella of machine learning and AI, eliminating some of machine learning's data processing with algorithms. Deep learning can be considered as a subset of machine learning. It is a field that is based on learning and improving on its own by examining computer algorithms. While machine learning uses simpler concepts, deep learning works with artificial neural networks, which are designed to imitate how humans think and learn. Until recently, neural networks were limited by computing power and thus were limited in complexity. However, advancement in big data analytics have permitted larger, sophisticated neural networks allowing computers to observe, learn, and react to complex situations faster than humans. Deep learning has aided image classification, language translation, speech recognition. It can be used to solve any pattern recognition problem and without human intervention. Deep learning is related to machine learning based on algorithms inspired by the brain's neural networks. Though it sounds almost like science fiction, it is an integral part of the rise in AI. Machine learning uses data reprocessing driven by algorithms, but deep learning strives to mimic the human brain by clustering data to produce startlingly accurate prediction. Artificial neural networks comprising many layers drive deep learning. Deep neural networks, or the DNN, are such type of networks where each layer can perform complex operations such a representation and abstraction that makes sense of image, sound, and text. Considered the fastest growing field in machine learning, deep learning represents a truly disruptive digital technology, and it is being used by increasingly more companies to create new business models. Deep learning is part of a broader family of machine learning methods based on artificial neural networks with representation learning. Learning can be supervised, semi-supervised, or unsupervised. So, what are the typical jobs in deep learning? Here we have software engineers, data analysts, data scientists, software engineers, bioinformatician, software developers, research scientists, full stack web developers, and natural language process engineers. Here the deep learning technique. First is classic neural networks. Classic neural networks, also known as fully connected neural networks. It is often identified by its multi-layer perceptrons, where the neurons are connected to the continuous layer. It was designed by Franz Rosenblatt, an American psychologist, in 1958. It involves the adaptation of the model into fundamental binary data inputs. Function of CNN. Here we have linear function and the nonlinear function. Linear function, rightly termed, it represents a single line which multiplies its input with a constant multiplier. While the nonlinear function is The neural network without any activation function in any of its layers is called a linear neural network. The neural network, which has action functions like ReLU, sigmoid, or TAT, in any of its layer or even in more than one layer. Three subsets of nonlinear function is the sigmoid curve, yun, hyperbolic tangent, rectified linear unit. Convolutional neural networks or CNN. CNN is an advanced and high potential type of the classic artificial neural networks model. It is built for tackling higher complexity, preprocessing, and data compilation. It takes reference from the order of arrangement of neurons present in the visual cortex of an animal brain. The CNNs can be considered as one of the most efficiently flexible models for specializing in image as well as non-image data. Here we have four different of organizations. It is made up of a single input layer, which generally is a two-dimensional arrangement of neurons for analyzing primary image data, which is similar to the photo pixels. Next, some CNNs also consist of a single-dimensional output layer of neurons that processes image on their inputs via the scattered connecton convolutional layers. The CNNs also have the presence of a third layer known as the sampling layer to limit the number of neurons involved in the corresponding network layers. And overall, CNNs have single or multiple connected layers that connect the sampling to output layers. The four stages in building CNN, which is the convolution, max pooling, flattening, full connection. Here, recurrent neural networks or the RNN. The RNN were first designed to help predict sequences. For example, the long short-term memory algorithm is known for its multiple functionalities. Such network entirely on data sequence of the variable input length. The RNN puts the knowledge gained from its previous state as an input value for a current prediction. Therefore, it can help in achieving short-term memory in a network, leading the effective management of stock price changes or other time-based data systems. Two types of RNN design, the LSTM and gated RNN. LSTM is useful in prediction of data in time sequences using memory. It has three gates, the input, output, and forget. While gated RNNs also useful in data prediction of time sequencing via memory. It has two gates, the update and reset. Number four, generative adversarial networks. It is a combination of two deep learning techniques of neural networks, a generator and a discriminator. The generator networks yield artificial data, while the discriminator helps in discerning between a real and a false data. Both of the networks are competitive, as the generator keeps producing artificial data identical to real data and the discriminator continuously detecting real and unreal data. In a scenario where there's a requirement to create an image library, the generator network could produce simulated data to the authentic image, then it will generate a the neural network. It would be followed by the image detector networks to differentiate between the real and fake image. Starting with a 50% accuracy chance, the detector needs to develop its quality of specification since the generator would grow better in its artificial image generation. Such competition would overall contribute to the network in its effectiveness and speed. Number 5, self-organizing maps. The self-organizing maps or SOM operate with the help of unsupervised data that reduce the number of random variables in a model. In this type of deep learning technique, the output dimension is fixed as a two-dimensional model as each synapse connects to its input and output nodes. As each data point competes for its model representation, the SOM updates the weight of the closest nodes or best matching units. Based on the proximity of a BMU, the value of the weight changes as weights are considered as a node characteristic in itself. The value represents the location of the node in the network. Number 6, Boltzmann machine. Number 7, deep reinforcement learning. Number 8, autoencoders. One of the most commonly used types of deep learning techniques. This model operates automatically based on its inputs. Before taking an activation function and final output, decoding such as bottleneck formation leads to yielding lesser categories of data and leveraging most of the inherent data structures. The type of autoencoders are sparse, denoising, contractive, and stack. Number 9, backpropagation. In deep learning, the backpropagation or backprop technique is referred to as the central mechanism for neural networks to learn about any errors in data prediction. Propagation, on the other hand, refers the transmission of data in a given direction via a dedicated channel. The entire system can work according to the signal propagation in the forward direction in the moment of decision and send back any data regarding shortcomings in the networks in reverse. First, the network analyzes the parameters and decides on the data. Second, it is weighted out with a loss function. And third, the identified error gets back propagated to self-adjust any incorrect parameters. Number 10, gradient descent. Example of deep learning. Here we have the virtual assistants. Whether it's Alexa or Siri or Cortana, the virtual assistants of online service providers use deep learning to help understand your speech and the language humans use when they interact with them. Next, translations. In a similar way, deep learning algorithms can automatically translate between languages. This can be powerful for travelers, business people, and those in government. Next, vision for driverless delivery trucks, drones, and autonomous cars. Next is chatbots and service bots. Chatbots and service bots that provide customer service for a lot of companies are able to respond in an intelligent and helpful way to an increasing amount of auditory and text questions thanks to deep learning. Next, medicine and pharmaceuticals. Internet of Things or IoT. So, what is Internet of Things? The Internet of Things is a network of connected smart devices providing rich data, but it can also be a security nightmare. IoT is a catch-all term for the growing number of electronics that are not traditional computing devices, but are connected to Internet to send data, receive instructions, or both. There's an incredibly broad range of things that fall under the IoT umbrella. Connected smart version of traditional appliances such as refrigerators and light bulbs, gadgets, and could only exist in an internet-enabled world such as Alexa-style digital assistants and internet-enabled sensors that are transforming factories, healthcare transportation, distribution centers, and farms. The Internet of Things How does the IoT work? The first element of an IoT system is the device that gathers data. In the next step in the IoT process, collected data is transmitted from the devices to a gathering point. Moving the data can be done wirelessly using a range of technologies or over wired networks. Data can be sent over the internet to a data center or the cloud, or the transfer can be performed in phases, with intermediary devices aggregating the data, formatting it, filtering it, discarding irrelevant or duplicative data, then sending the important data along for further analysis. The final step, data processing and analytics, can take place in data centers or the cloud, but sometimes that is not an option. In the case of critical devices such as setups in industrial settings, the delay of sending data from the device to a remote data center is too great. The round trip time for sending data, processing it, analyzing it, and returning instruction can take too long. Here, how the Internet of Things work. First, IoT devices gather data and send it through the Internet for processing. Data is analyzed centrally, and last, instruction-based analysis are turned to the devices. IoT and business applications. Oil and gas. Isolated drilling sites can be better monitored with IoT sensors than by human intervention. Agriculture. Granular data about crops growing in fields derived from IoT sensors can be used to increase yields. HVAC. A climate control system across the country can be monitored by manufacturers. Last, brick and mortar retail. Customers can be micro-targeted with offers on their phones as they linger in certain parts of a store. Advantage of Internet of Things or IoT. Here we have communication, automation and controls, information, monitor, time, money, automation of daily tasks leads to better monitoring of devices, efficient and save times, save money, better quality of life. Disadvantage of Internet of Things or the IoT. Here we have compatibility, complexity, privacy, security, safety, lesser employment of menial staff, Technology takes control of life. Smart cities, home automation, industrial automation, health monitoring, smart environment, Internet of Things applications. Here we have smart home, wearables, smart cities, and connected car. Internet of Things devices and examples. Here we have Amazon Echo and Google Home sa ating smart homes. Fitbit, Charge 5 wearables, Barcelona Smart Cities, AT&T connected to car. Augmented reality versus virtual reality. What is augmented reality? What is virtual reality? What are the augmented reality and virtual reality? Here, augmented reality and virtual reality are reality technologies that either enhance or replace a real-life environment with a simulated one. AR augments your surroundings by adding digital elements to a live view, often by using camera on smartphones, while VR is completely immersive experience that replaces a real-life environment with a simulated one. In AR, The difference between AR and VR. Both technologies involve simulated reality. AR and VR rely on different underlying components and generally serve different audiences. Example of augmented reality and virtual reality are uh, IKEA Place is a mobile app that allows you to envision furniture in your own home by overlaying a 3D representation of the piece, a live video stream of your room. You can make Let's user virtually try on real-life cosmetic via living selfie. Repair techniques can do a headset that walks them through the steps of fixing and maintaining a broken piece of equipment, diagramming exactly where each part goes and the other in which to do things. Various sports are relying on augmented reality to provide real-time statistics and improve physical training for athletes. Some business examples of virtual reality include architects are using VR to design homes and that clients walk through before the foundation has ever been laid. Automobiles and other vehicles are increasingly being designed in VR. Firefighters, soldiers, and other workers in hazardous environments are using VR to train without putting themselves at risk. The components of an augmented reality system. Here we have the processor, display. Under display, we have a mobile handheld device, wearable device, automotive HUDs, and others. The camera, other sensors, input devices. Here are types of software algorithms needed to enable augmented reality. This includes the image registration, the content management, 3D rendering, interface, development toolkits. What are the challenges for AR and VR? In technology challenges, we have limited mobile processing capability, limited mobile bandwidth, complex development, and in business challenges, we have VR hardware inconvenience, building a business model, security, and privacy issues. The advantage and disadvantage of AR and VR. That's all. Thank you very much and God bless.